Algebros, welcome back. In this video I'm going to show you how to sketch the graph of f of x equals log base 4 of x minus 3, this time using the graphing calculator. To start things out, what you might want to consider doing is rewriting the function using the change of base formula. So what that means is in y1, instead of typing it in as log base 4 of x minus 3, which is something you typically can't do with your graphing calculator, select the change of base formula either using the common log or the natural log version to rewrite this as something you actually can type into your graphing calculator. I'm going to roll with the common log version of the change of base formula, and if we want to rewrite this using that version of the change of base, it'd go log of the original argument, which is x minus 3, divided by, so if you hit the divide key, get that slash fraction bar, log of the original base, which is 4. Alright, if you wanted to use the natural log version of the change of base, you'd be welcome to do that. And you'd have the natural log of x minus 3 divided by the natural log of 4. Alright, but if we roll with this one, let me go ahead and pull up my graphing calculator. And I'm going to go ahead and hit the y equals key. And in y1, we want to hit the log button. Now type x minus 3. Scooch that up a little bit more. Alright, be sure to close off the parentheses. Now hit your divide button. Press log again. Hit 4. Close off the parentheses. And now per the usual, let's hit zoom, option 6. And that's all you get from the graphing calculator. So you can kind of see some of the elements of a typical log graph there. It is kind of rolling out towards positive infinity in kind of a slow fashion, but what the graphing calculator is not providing you with is the vertical asymptote, and it's a little bit difficult to see where this graph is crossing the x-axis. So with that said, what I'd like to do is sketch the original function out using transformations, just so that we can, number one, verify what we're seeing here, but also include some of the other important details of the log function graph. Let me go ahead and X this out. And if we were to do this in the style of transformations, we'd want to get a base graph going. And based on the original version of the function, the base 4 is larger than 1, so what you'd wind up seeing happening with the base graph is it'd start near the negative part of the y-axis on the right-hand side, cross the x-axis at 1, 0, and then just roll out to positive infinity, and that would be our base graph. Since the argument has x minus 3, in other words, we're directly subtracting 3 from x, that's going to be a shift to the right by 3 units. Alright, so 1, 0 is going to be helpful on that regard because this is going to have to move to the right by 3 units. Alright, and that now puts it at 4, 0. So our graphing calculator should be showing the graph crossing at 4, 0, but again, it's kind of a little pixelated, so it's a little difficult to see. But what's also important to move to the right by 3 units is the vertical asymptote, which starts out along the y-axis. So that's going to have to move over to the right by 3 units. So 1, 2, 3. And that's definitely something your graphing calculator is not providing for you, but with our knowledge of transformations, we should know that that's there anyway. And the equation for that, by the way, would be x equals 3. That's really it in terms of, transformations. There's just one, and that's a shift right by 3. All we're going to do is just redraw the shape from the base graph on the right-hand side of the newly located vertical asymptote, and also going through the new location of the x-intercept, which is now at 4, 0. Alright, so, graphing calculator, it will kind of give you a sense of what the log function graph looks like, but it's never a bad idea to refer back to transformations to get some of those other details that are a little more difficult to infer from what the graphing calculator gives us. Alright, but either way, if you need to type a log into your graphing calculator, the best way to do it is to use a change of base formula. And that's really the point of this example. So I hope I was able to successfully demonstrate that for you. If you have any questions, just let me know. Otherwise, thanks so much for watching.